All right, let's up that level. Let's keep going. Let's start off with one. Now, we're starting to get into closer to test level stuff. This is fair. It's not too much. It's actually fairly straightforward. So, we have a couple of options. We're trying to find our u. We typically find u's in one of two places. Typically, not always. Either in denominators or inside of functions. Now, if you choose u to be x squared, there's nothing to cancel out with. So u is not going to be in the denominator. So our next choice is, well, let's look inside of a function. So let's try this. U is equal to pi divided by x. Now, I'm going to skip to it since y'all took calculus 1, right? You took calculus 1, didn't you? So this is negative pi over x squared dx. The derivative of 1 over x is negative 1 over x squared. The pi just goes along with it. I'm not explaining that stuff. So, hey, look at this. We have our 1 over x squared dx. Let me write it out a little bit different to make sure we can see it. Because the denominator is the same. We're looking for this. You know, broke it up, got it out of there. We're looking for that 1 over x squared. So why don't we divide out that negative pi, and we're going to end up with 1 over negative pi du is equal to 1 over x squared dx. Now we have our u, and we can get rid of our 1 over x squared dx with that negative 1 over pi du. So let's do this in the same way each and every time so we don't make any silly mistakes. So first thing I want to replace is the u. Next thing we want to do is get that 1 over x squared dx, and that's negative 1 over pi. Doesn't matter where the negative goes, even though I keep saying it incorrectly. Du. Now we're done. Let's take the antiderivative. Oh man, cosine. Take a breath. Take a breath. Take a breath. And we're like, we got our negative 1 over pi, and then the antiderivative of cosine is positive sine, so we get sine of u plus c. Now we go through and we replace, so it's sine of plus c, and we just pop in our u again, pi over x. And there's our solution. Fun with integrals. Let's keep going. All right. Hey, this is a good one. I like this problem. You're going to see problems like this quite a bit. So make certain, if you catch nothing else from these, make certain you can do this problem here. Here's the trick. You try and take it. I'm going to do this in a different color and be like, u is equal to 1 over x squared, right? It happens sometimes. So the du is going to be equal to 2x dx, and then we look over here and you're like, dude, I can't get rid of that. It's not going to work. Crap. But this happens. Be okay with this. You are in Calc 2. You are going to go the wrong direction sometimes. That's how we find the right direction. It's process of elimination. Now on this, we need to know that you can never, ever break up a denominator, but you can always break up a numerator. So we need to do a little bit of algebra first. Actually, I'm going to write that. I'll do it this way first, and then I'm going to change it. Hey, we can find antiderivatives on that. I know the antiderivative of 1 over 1 plus x squared. That's inverse tangent of x. And then the x over 1 over x squared, I can find that. I just have to do a u sub. But the thing is, I'm going to have to do a u sub. And I'm going to have to mess around with that inverse tangent. So we actually have to do them separately. So here's some rules of integration. I'm going to solve in this manner. Okay, so let's do this instead. Let's take this up here, and now let's start the problem. Should move this over a little further. There we go. All right. So we can initially just right away, boom, boom, boom. Antiderivative 1 over 1 plus x squared, must know it, inverse tangent of x. And there's a plus c. Plus, and now we can handle this antiderivative. Oh, I'm sorry, integral. So let's say our u is equal to 1 plus x squared. Hey, that's the original thing we were trying to do. And then we get 2x dx. Moving faster now. So the 1 over 1 plus x squared, that's just going to be a u. And then we're going to end up with our x dx, which means divide out your 2, and you're going to get 1/2 du is equal to x dx. And then we can replace that out. So let's get it. So we're going to end up with that. Oh, I say do it the same way every time, but I'm starting to move faster now. And we have our inverse tangent of x plus c. And now let's take our antiderivative. You see that I'll skip a step here. Like, what about that plus c? I'm going to throw it at the end. Do you know what c plus c is? C. Only with the constants, okay? And now we just have to make certain that we replace our u with what it equals, which is 1 plus x squared, and we have our answer. So it's inverse tangent of x plus 1/2 the natural log of the absolute value, not needed. Not needed. Not needed. When is 1 plus x squared negative? It's not. It's always positive. Now, you can leave your absolute values in there. It's not wrong, it's just redundant. So I took them out because there's no need. In a Calc 1 class, I'd always put it in, but now we're in Calc 2, we need to start seeing shit like this. Oops, sorry about the swearing. I'm trying to get better about that. At least not being recorded. All right. Dun, dun, dun. All right, x squared over x squared plus 1. This is a tougher one. Now, there are multiple ways of solving this problem. We could do a u sub right away, mess around with our u, and solve, because you can always break up a numerator, but you can never break up a denominator. We could do long division, but I'm doing this because I want to teach a trick to y'all, if that's okay. Can I just teach you a quick trick? Is it okay if I add 0? Can I just add 0 to this? Does it change anything? Of course I can add 0. I can't add 4, but I can add 0. It doesn't change anything. So I'm going to add 0. 1 minus 1. Just going to add 1 minus 1. And you don't have to do this trick. This is just a fast way to get through some problems, and I want you to see it. So what do we got here? We have x squared plus 1 over x squared plus 1. Oh, I'm sorry. There's a minus 1 here. Do you see that they match if we just break up that numerator? Oops, plus. We're going to take this minus 1. We're breaking up the numerator. Oh, goodness. Same picture over same picture. I'm pretty sure it's just 1. My goodness. Problem over. Problem's over. Antiderivative of 1 with respect to x is going to be x minus inverse tangent of x. And just don't forget your plus c. Take it or leave it. You don't like that trick? There are other ways of solving this problem. I could have said that u is equal to x squared plus 1. Oh, no, that wouldn't have worked. Never mind. I thought it would have worked. Dang, that wouldn't work. So you'd have to do long division instead. So I was wrong at the beginning. I'm not remaking this video. Yeah, I can see 2 ways through the problem, not 3. I got a little crafty. I'm a little out of practice. It's been almost 2 weeks since I taught, so. There it is. All right, we'll have one more for our 5.5, and I'm going to bring the heat if that's all right with you. Cool. I'll see you in the next.